Okay, so yesterday we stopped in some seeing some use cases, right, where ethics is very important, responsible AI needs to be accounted and taken into consideration. And here I just show just a little bit of another application where you might think, what does this have to do with cultural heritage and AI, with responsible AI? So this is another example of how the responsible AI principles can be taken into account in your research, in your daily research. In this case, we propose, this is just an example, we thought that all these tools that you have seen, generative models that generate an image based on a text that you say, okay, an elephant, a pink elephant flying on the beach, and it generates the image for you. This is just one example, but what about, I think, the image captioning techniques? I think they could be very useful for minorities. So blind people, if they cannot go to a museum like we can enjoy art, it would be nice also to be able to express them with words what it's exposed in a museum, right? So image captioning models could be one solution for that. So what we propose in this paper is including minorities as a special user and evaluator of the latest explainable AI techniques and AI techniques in general, in order to define some catalytic scenarios to help work in these groups together for collaboration and improve user experience. We pose some challenges and some research questions that should be still addressed by current AI techniques. So this actually relates to the principle of inclusivity in the AI principles, which basically demands for including all the minorities and diverse group of stakeholders and audience of our explanation. So indeed, it's one way also to attain responsible AI. This is, for instance, defined in the US standards and other principles, right? So it's still part of all guidelines of being inclusive and not having systems that can provide discrimination, so according to your condition. This is another survey we have on if you are doing more robotics or control, you can find how explainable AI applies more to these topics. It's not as straightforward, perhaps, or as clear solutions yet existing for these methods, but we did a brief overview on what exists right now. So a little taxonomy, as the one presented earlier, where we have transparent algorithms, post hoc explainability, and different ways of learning, and attending also to different input data, like can be images, text, or tabular data. So here you can see in the Pong game, like where the network is paying most attention to, it seems reasonable that it will be looking at the actionable, the movable block to shoot the ball, and to the areas in which the strategy to win is key, like getting the ball inside here to break all the balls. So we can somehow debug a bit the reinforcement learning models with these saliency methods. This is just an example. These are other methods that maybe may try to extract a graph of the underlying agents and elements in the game taking place, or according to actions that they can take, and entities and their interactions. We also have, apart from attention mechanisms that serve to identify the important parts of the picture, as we saw, by providing a distribution of over attended areas in the image. Here we can have the entities that are key for explaining a process in the decision making when we are learning a policy in reinforcement learning, for instance. So we can have let's say a path of the states in which the agent can have like a causal chain, where to say, okay, this is the most strategic way to achieve the objective faster, right? So as you can see, the explanation can take many forms. There is not a unique way of or a standard gold standard of having an explanation for each reinforcement learning algorithm, but it will depend a lot on the use case. So here you can read more examples. And for instance, some other recent work we work on is where we try to demonstrate. I don't know if you know this environment. It's a nice, simple environment, but very nice because it doesn't just look at reward, but also sustainability aspects or peacefulness. So the trees are in green and they have apples, so the agents can be very greedy and just want to eat apples, and they may kill the trees if they are too selfish and not leave others or don't leave the tree recover. But of course they need also to survive. So there are other more social good or social metrics that it will be nice to explain, right? The behavior of the system as a whole. So it'd be nice to ask, can we explain the contribution of each agent, but according to all these behaviors. So we demonstrate that it's possible to explain some of these social metrics from the commons good environment. However, there is some challenges still to solve, as some metrics do not account for time, and this is key, for instance, for sustainability. This is related to all the green computing and green AI paradigm that it's becoming more and more important, unfortunately, with the energetic crisis. And these are maybe key. So there is work still to do, of course. So if one agent it's kind of inconsequential or not maybe to thought, it might be that all the environment goes to trash, all the ecosystem, right? So I think these are important tools that we need to work on also to model. It's okay to start with little games like this, but there is a lot of work to do. So another ideas on this area, as you see, attention or somehow ways of explaining saliency are other ways where they can also apply to text. And so we can take the human explanation as a ground truth, or the trustworthy, let's say the right explanation for why a text may be classified, let's say, as spam or not spam, or as offensive or not offensive, right? But this can be a delicate issue, and as you know, we humans most times don't agree or don't get into agreement sometimes, so it might be a problem sometimes to have reliability only on the humans also, even though they are normally we consider the ground truth. We may need some additional more programmatic metrics, right, to not depend on humans. This is normally a challenge to keep in mind. So this is just, for instance, one example called Marta, and they map the human rationales to attention and updating, somehow correcting the explanation in green. The intensity of the green, which is not very much seen there, can show the intensity of the impact on of the relevant sentence. And for instance, some mechanical Turk workers, the annotators of how much is important for a task in the text, they may be more minimalistic selecting sentences or more general. So it's very difficult just to show you how difficult can be evaluating the explainability in these models. Also, if you remember, we talk about all saliency maps and heat maps and When it comes to the latest models using attention mechanisms, that is basically a contextual way of accounting for context in your input data. There is a big controversies and showing that attention is not always an explanation. There is also answers to these papers that attention is not explanation. So it's hard to verify or to have a strong conclusions. And so the controversy is basically at the end, what they conclude is that saliency may be a tricky signal, that we must not trust only in saliency as an explanation, right? Because it may be sometimes what we expect or what we want to see, other times not. And so when diagnosing poor generalization like there, actually this is good, from the Benjo's lab, Mila lab, even though it says anonymous, but so it shows very well that it's not something unique to trust. So this means we need to think radically different sometimes approaches, right? Even though that's what we have right now. Also there is some additive explanations, compromises that we need to be aware of when we use those methods. So if you're interested, you can read those papers. Okay, so in terms of these controversies, as you can see, we need some more disclaimers for our models. Like attention might be one mechanism but for enhancing performance, we might need some other things, and also explainability according to the audience we want to showcase or explanation, the one that is waiting or explanation. So we are also working on a set of disclaimers that should be giving us requirements for a model of input, output, for what is the system use. Like in the AI Act right now, the aim of the model should be very well stated, and so that it's not used outside of that purpose initially specified in the documentation, which, by the way, the documentation as we understand it is nothing compared to all the documentation we will have to provide to comply with the AI Act. So we need to be ready to document much more and much better. So in transformers, of course, this attention has shown that sometimes what we expect as humans, for instance in text, to be the keywords of a text to maybe classify it as discriminative or aggressive versus neutral, it's not always what the actual transformer is deeming as relevant. This makes us skeptic about using these methods. They might need some improvements. We might think different approaches, but in fact, we need more research in these areas. And it's an interesting topic since transformers are now the state of the art, as you probably know. So this distribution, when they are inconsistent with the importance of the input units as measured by gradient-based methods, make us need extra unit tests to properly explain. Also, adversarial distributions can mimic this and somehow provide a totally different picture. We need to account for that. So maybe some formal methods like probabilistic model control could somehow, we could borrow from the more formal methods disciplines, some more formal approaches to verify, certify that. I believe the validation and verification of in the software engineering area could be something we could get inspired to applying AI, since we don't really have so well specified software engineering requirement and techniques to certify along the process all the operations at the ML ops, also not just at the model level but also at the full pipeline of ML ops and DevOps. So not only for the black boxes, but their compliance and the also requirements specification. It's not always easy to map your requirements to the actual model, right? Okay. So this ends the first part of approaches, but I want to go a bit deeper in how to apply explainable AI. So the lecture today it's a bit more oriented to, okay, how we apply these principles in practice. If you're working in a company or just to test your model and be more sure about the guarantees of your model, there are many frameworks. So here you can see just a set of those. I believe for exploring your data and having wide diversity of tools, I suggest AX360, which is the IBM framework, because it has very nice documentation, very nice web demos that are interactive. You choose your audience of your explanation, the method according to your data and your model. You explain one way or another. So as you can see, it provides quite versatile functionality. It provides also help to know which method to apply. It's not always evident or intuitive to know which method to apply. When it's model agnostic, you can try always, but it's not always evident. So you can say if we want an interactive explanation with your user that you can interrogate and refine, or that's of course problematic, as you can see here. It's not always evident that there will be a solution to satisfy the human, but also to understand the data, the model, the distributions, the samples, the features, depending on your model, if it's generative or not. For instance, if you have an explanation of the full model or just a concrete example that you are very much interested in a data point, so local versus global explanation, or if you have a directly interpreter model or a post hoc one, or a surrogate model, like we said yesterday, a mirror model or a mimicking model that simplifies your original model, and therefore you're explaining not a twin, you would like to be a twin, but a different model than the original one, but ideally you will understand it better. So this is a bit the techniques that the IBM toolbox provides and the kind of data. So you can adapt your problem to fit in this problem, in this tree. And okay. So in the larger picture, you may see, okay, once I explain some model and I'm more or less satisfied, that's just one little part on the MLOps pipeline, right? For deployment, for keeping your model running, especially in continual learning, as many of you are familiar. Your model may get worse metrics. They will need to be controlled. Like in the AI Act, you will have to monitor under which confidence values your model should be performing, what level of error is permitted. So you need some control over this. So debugging and improving these explanations. So there will be a lot of job for us, a lot of tasks to do. We need help, and here you just have a bit of the links of the papers that, if you want to find more about the technique, you can go more to the theoretical motivation of each technique explained in this tutorial of IBM. And for instance, this is if you want to follow along, you have the link here. You can see, for instance, okay, we want to have the FICO dataset, which is the explainable machine learning challenge for credit scoring of a company, to predict basically if it goes in bankrupt and they cannot pay back. So it's an anonymized of home equity line of credit called HELOC, made by real homeowners. So this line, the focus is like basically we have a bank of let's say the customers in this dataset have requested a credit line in between $5,000 to $150,000, And the fundamental task is basically to use this information about the applicant in the credit report to predict whether they will pay back this credit in a 2 years' time. And not only that, but they also predict how much credit should be extended, like or how much probability it would be like to pay back, right? Okay, so we want to explain the models to a data scientist like you, a loan officer, and a bank customer, which is the affected one. So the, let's say, end user or the consumer could be considered as the loan officer. So they are different, as you can see. So depending on those, we can proceed forward in the tutorial, and it explains you how approved credit users are handled and why the model predicts so, and denied user. So in this case, we can use the model contrastive explanation method, CEM, which or proto-dash you can use also depending on the final audience of your explanation. And basically this method comes to rescue, to adapt to these different scenarios where contrastive explanations are used. And what does it mean? It means normally when people ask an explanation why this event, they normally mean why this event and not this other, why the event P happened rather than event Q, right? We want to compare with another, what would be the difference, right? So they clarify why an event occurred in contrast to another. That's why it's contrastive. And they are inherently interpretable and intuitive to humans because we think a bit that way. So you can see, okay, why my application was rejected and how can I improve my likelihood to improve my credit because I want to buy a house. So in this method you can, you can compare with other users or point at the right variable that actually made you how much far from reaching that level, right? Because we want to improve our likelihood to be given the credit. So, for instance, we have 3 users we can choose. One, Jason denied, Anne denied, and Julia denied. So, some features fail outside the acceptable range. And here, this method provides you these informal rules that are actually natural language, so very easy to understand and in an universal way for everyone. So it will say, okay, the value of the consolidated risk marker is 65, so it needs to be around 72 for the application to be approved. Also, the average duration of your account in our bank, it's not long enough, so we don't have enough credit that you are a reliable person. Or and it tells you how much it should be for it to give you an idea of the how far you are, right? And the value of months since the last request for credit cannot be in the last 7 days, and you did it after 2 days. So that's easy to fix, right? But others are not as easy. So these are ordered in relative importance of, let's say, actionability or of how much work you need to do, right, to reach there. So they can be improved in this order. This is in order to improve the likelihood of being accepted, as you can see here. So this is a nice method. For instance, another denied user, let's say it also points at delinquency score, and apparently she has some records, so this clearly it's one of the important ones. But she also has risk markers and satisfactory accounts, not enough, right? Okay, So inconvenience of this method, but so you are working with images, you cannot name every pixel, right? This is nice when things are nameable and tabular data. So it's very like a fairy tale, nice. But if you're not working with tabular data and interpretable features with text, you cannot have an explanation for each word or each bigram or engram, right? So okay, we continue. Another method, for instance, is proto-dash. This is also like CHEM, like contrastive explanation method. Also allows to have inclusive, the inclusive principle we were talking, because it allows to keep in mind the different audiences and adapting to it. So it does not give feature importance like we saw yesterday, for instance, with Sept, but it gives a vector of same dimension as the input, so you can compare with similar individuals and see how others compare to you and why others got the credit and you didn't, right? Which can be very useful. When to use it? So when you need reproducible explanations. So reproducibility, is very important. When we need to optimize for diversity, picking prototypes that are representative and diverse, which this might not be the case when you just choose the closest neighbor according to some metric. So because you want to capture all different segments in the data set, this is something that it's nice in this method. As you will see, and you start to see, one explanation does not fit all purposes. And you can read this paper from the IBM authors that motivate a bit this. Okay. In this method, as you can see, the vector that it's given to you here shows all the features, and it gives similar customers that were evaluated, and they had most of the features like this particular case, but were denied the credit. So this is also just to explain that these are shared and you are not discriminated, right? Because it's the similar case. So it just shows also that, and how this is just a generic rule. And also you could see the different, very similar people, but with similar, let's say, traits. As you can see in blue. In blue are the same feature values to that input customer that we are interested with. This shows the closest similarity score to this particular data point that we want to explain, but maybe a different feature that makes them get the credit while this customer couldn't have it. Okay, now let's move to, I know most of you are interested in images, or a lot of people because you are in the image lab. So some of you, or most of you, I guess. Okay, so another example that is giving a nice tutorial also you can follow along and play with. This is what for dermatologists we want normally to have expert aligned explanations, right? So if you ask a dermatologist to classify the lesions into the 4 different concepts, from melanoma to something benign, normally we all know by common sense or by experts that they should pay attention at dimensions such as size, roundness, darkness. When it changes color, you need to control. The border definition, when it becomes to be irregular, it's need to control for it. So this is a bit summary, of course validated by experts. So we want these explanations to be more high level, not just at pixel level, but aligned with human expert interpretable concepts, right? So how do we do it? So we want to learn what is called disentangled latent features with a variational autoencoder. This is the baseline used here, and a deep VAE, which uses a disentangled inferred prior variational autoencoder. So the idea with this method is kind of interpretable, more interpretable by a unsupervised manner. So you don't need to predict, let's say, a degree of roundness or degree of a smooth surface or homogeneous color. We ideally don't want to do this tedious task, right? But we want this latent dimension to be somehow, when we say disentangle, is discriminating in our vector of representation that is learned with deep learning. And we want this to have some semantic meaning. So one way to show if this is happening is by making these grids of images, where once we have learned this representation with the generative model, we can generate all the different values in our range of our normalized values and plot the generated image with that vector that we have learned to see what is representing each component in the vector, right? To see if it makes some sense or some dimension, as the dermatologists would expect, is somehow captured in the data generating factors. So here you see the one-dimensional features that vary in -3 to 3. They have been normalized that way. And when it increases, so you vary this part of the vector to have this range from -3 to 3, a corresponding lesion, a skin lesion, will increase in size. So we can see, okay, these components of my feature vector is in charge of modeling size. While this other component, if we look at it from, as you see here, this image from going up, down, you can see that it seems really including size for each sample. So it seems coherent to be representing that. And here you can see that it starts from circular on the top, and as you vary the values down, it generates images that are more oval. Okay, as you can see, this is somehow intuitive for us to appreciate, but how to quantify how much all your generative models are more explainable one than another, it's not really quantitative. So this is a bit the problem if we want to quantify. How do we distinguish among this grid and another one? So these are interesting research questions we have to pose ourselves and try to find ways to measure. So this tutorial is also online for you to follow along if you wish and play more. So the idea is, can we use these disentangled latent features instead of the ground truth attributes, because we don't have the roundness label or the ovality or some kind of homogeneous metric, right? So the idea will be that actually. So in this case, we use 10 dimensions from the latent code as attributes. This is also hard to explain why we choose 10 and not 4 if we are looking at 4 dimensions, right? This is deep learning, things that still we just learn by doing, but it would be nice to have unexplainable mechanisms to determine this. So far it's just experimental. Another research in the area that is interesting. But the nice thing of this model, like autoencoders and variation autoencoders, is that this they maximize the likelihood of generating new examples that match the learned data, and because of that, they should learn inherently these dimensions. So if we remember about size, roundness, darkness, and border definition, these are the ones we really want to be captured when we make a slider, let's say a slider from one feature to another to be observed, right? So For inferring these disentangle factors, the inferred prior of expected variational posterior should be factorizable along these dimensions. This is a requirement of this method. The simple way of adopting this strategy as an effective approach to do this is matching the moments of the two distributions in order to decorrelate the dimensions of the inferred prior. We will not go into details, but just to give you an idea of the behind, you can read more the paper if you want. And the idea of this data set is called SIG, is to show the utility of these representations in a downstream task, meaning another task that after you learn to generate all this data, you can use this representation to classify in a more effective manner without using all the pixel information, but just 10 dimensions if the lesion is melanoma or some other kind. So here you can see a bit the code of how this could look like. So the directly interpretable and supervised explainer, which is DIP VAE, those are the acronym. You can import it like that from the library. You specify your data set, your CUDA as usual, and the arguments, and it provides abstract methods that allow you to somehow synthesize quite a lot the code nicely without seeing too much complexity behind the scenes, to focus on the analysis, which is nice. And this is similar with the Proto-Dash explainer or the Deep VAE explainer and other methods. Okay, so you can initialize the Deep VAE explainer with the pre-trained autoencoders, like here, this way, and the VAE explainer is just a pre-trained generative model, and this can be used to introspect the learned generative model. The VAE is used just as a baseline to compare with and see if we improve the explanation, right, with the Deep VAE. So the explain method takes in the images and returns the modified images generated after altering or changing some latent dimension in isolation. So keeping the rest fixed, and let's say, okay, if we found that the first dimensions of the vectors affect size, let's keep the other fixed and see if changing these components, three first components, the size change. And we can display these grids of images, as you saw, to an expert to see. And actually, I think this is a good practice to say, hey, do you think we are capturing here all the factors of variation as you deem is relevant for classifying a lesion, a skin lesion, as dangerous or not? So they may say, okay, the surface is not being taken into account. What can it be? Oh, okay, maybe we are not having enough resolution of the image, and that's not appreciated. But they may say, okay, it seems like you have captured all possible disturbances somehow. This is, of course, difficult, but it's an approximation, right? And so once they maybe think that all those latent dimensions have been somehow learned by the data, and our generator can have diverse enough umbrella, a spectrum of all these types of lesions, maybe we can move on and try to explain this model better or use it for another task. Here you can see, for instance, is the hair important in the classification of a mole? Probably not. It seems that not. So this is the input, and the output, if we apply our learned representation of our generative model on this image, and we later generate to reconstruct it, look, it kind of ignores hair. It means the hair is not a relevant dimension to to learn the key components of classifying a lesion. In robotics, we say this is a distractor. The hair is distractor. So this is important, right? Because it might be important, it might not, but it seems in this case it seems intuitive, I guess, according to a dermatologist, that is not. So it's good. It's learning the important things. It's throwing away other information. How do we evaluate actually this? This is still very interesting case for me, even though we need the expert and everything, but we should be able to do a lot of work without the expert before. Like, does this reflect some kind of factors that we would think are aligned with the expert? So if we do the latent traversal of this vector that we have learned, varying a single latent at a time while keeping the other fixed, ideally they just control a generative factor, right? So here it seems that the fifth dimension is capturing the notion of diameter. If you see here, right, it seems that it's very small. As you augment this latent variable on the x-axis, it becomes really bigger. So that seems like the diameter. While the 0, 2nd, and 6 here, they seem to capture the border definition. Would you agree? It's not super evident. You need to pay attention. So you can see here it's very blurry. It becoming more defined border, right? Border here is like how sharp is if we will have to do a segmentation of this lesion, how sharp it is. Here it seems also from very defined to very, it seems to be in the opposite order, but also from very unconnected components to very connected cohesive form, the morphology, right? And in the 6 it's a bit similar. This is a bit harder perhaps in the 6, right? Because it changed quite a lot the form, but more defined definitely here and less defined here, more blurry. And the first dimension, what do you think it could capture? Which is the second row. What element from the ones we said you could think it could be capturing? Ovality? Yeah, it could be. It's sometimes not obvious, as you can see. Here they indicate it's asymmetry. Also in the second model, one is the VAE and the other is the deep VAE. Above it looks a bit more defined, as you can see down below. But indeed, both models, also the VAE baseline down, it seems a bit the asymmetry, which is related to ovality. Yes, indeed, look here, it looks like a little fish, very long, and here it's very symmetric. Okay, good. So as you can see, this is not an automatable task. If you train a network with many parameters and you need to look by hand at all these grids, it's not so automatable to say, okay, this is more explainable than other. So as you can see, it's very intuitive, but very qualitative, not quantitative. So it would be nice to match somehow explainable AI metrics to this visual metrics, right, to validate our model. So this is what current research and people like you and us, we should be thinking of. If we want to give a certification to a model that is doing this classification, how do we automate this? How we provide a test that we run and automatically gives a score that we can compare as we compare accuracy, precision, recall. It's challenging. So I'm very much interested in these topics. Let's see some other analysis. here you can see like if we plot the let's say the confidence P of the model predicting one of the classes. We have 4 classes: melanoma, nevus, pigmented, dermatofibroma. So some are classified with high confidence compared to other classes. And you can see here, when you go from left to right, the confidence P of the model, that sometimes when you come more to the right, there is no samples that are really high confidence. So this is something to keep in mind if we are giving this to our doctor, and we believe that it's not a clear case for the expert, because it should be taken with caution. So the images the plots that don't have the distribution of the values, or like here they don't have a plot, or here, they basically represent on the right the values of the latent dimension for each being of the classifier confidence P, but when the error bar is too small, it's not appreciable. Here it's not visible, it may be empty, or there might be no instances with that confidence, right, which it can be a reality. So yeah, on the x-axis you see it's the latent dimension, right, and the confidence value on the y. So in the tutorial you can see, okay, let's learn just a random forest. Let's start with simple models first, and you could start something like this that you are probably very familiar. You say, okay, we got 69% accuracy using random forest, and then let's compare now with the neural network. We see we get 88% with an ensemble of deep neural networks. And we plot the distribution of latent features for each class in the test set. And so we see that we gain, of course, some performance is important, right? But we lose explainability. So now we have that's why we need to have explainable model is key here. So here with this plot, we can see how much disentanglement we have with these different latent values for each class in the test set, and perhaps somehow comparing this. From these plots, we can see that the classes melanoma, nevus, and pigmented are classified by the model with high confidence compared to other classes. The border attribute in melanoma and nevus, which is the component 2 and 6, becomes stronger with increasing confidence. So these are some deep analyses you need to be looking, for instance, and it's hard to assign a single concept to a single dimensions, as you can see. This is a hard task, right? It's not always evident. So we need methods to speed up and to improve these pipelines. Maybe some higher values of some latent values become more sharp and well-defined for lower values, or for lower values of border tends to be less well-defined. So this is some way in which we can maybe measure monotonicity of our, to give a quantitative measure of the model learn representation. So yeah, we can think of other metrics in explainable AI that could help here. But basically, we can, as we can see from this plot, 10 dimensions maybe is not enough. You maybe try more dimensions. Then how you compare these plots, these grids? They may be not be fair to compare, but we still need some quantitative metric to see if one model is better than another. It's not obvious. So I'm trying to raise you with all the problems you can find, and probably many more. So this is why this area is exciting and needs a lot of thought on improving this method. Also, it might be that, as we said, the resolution is not enough and some aspect it's not learned. So we need more principal approaches to improve this model, let's say, and explain them better. So, as we can see, at least the visual explanation are much more explainable, let's say, by non-expert. This is a nice thing of this method, right? We can see if the diameter augments or ovality augments, the roughness. So they can be more audited. We will need auditors of these algorithms, right? So it can be more less dependent on AI knowledge to debug it. Also, of course, they are more suited if they are more explainable, even if in this quantitative manner. They could be used by different stakeholders and to use for transfer learning as well, which is key today in many systems of AI. And they can better be shared or say, okay, I'm just interested in the shape and the diameter, just to classify car vehicles, wheels. So you just care about the size of the diameter, right? So you will just take your part, or perhaps it helps you speed up. So getting these insights and translating them into, let's say, recipes that work always is a challenge. But what is clear is these representations can help speeding up, being more efficient methods, and having more compact representations that are more interpretable and easy to manage. So when we say model-specific conclusion, so for this technique, we also have a confidence, which is nice. We can see, okay, for this class, the model is pretty certain, but for this other it's not. This is something not all methods provide, and it can be key. Or we already said this conclusion, so as possible solution. Okay, so now we saw some cases with tabular data, we saw some with images. Now we try to seek some numbers to compare our explanations, right? So there's not so many options. In this toolbox, explicitly you find monotonicity, faithfulness, in order to somehow measure the goodness of explanation. So we will go through them briefly. Because of course the human evaluation, it's good to have a 10, but we need some proxy, some number, right? Okay, the monotonicity basically measures whether adding more positive evidence increase the possibility of classification in a given class. So the intuition is that if the features you have that should be independent a priori are positively correlated with the decision, then the class probabilities should monotonically increase as you add them, right? So you start with the base value vector, and then you incrementally replace the features that have positive relevance with their actual values. So this means you need some kind of ranking your features, right, to give this experiment.
I have a couple of questions. I don't know if it's the right one.
Yeah, sure.
Okay. About the method you were showing us before. I come from the industry, so not research. I work in a company that provides machine learning models for banks and insurance companies and so on. About the method, you showed us an example of images, of course. I actually work with transactional data, so instead of a picture, we have all your transactions in the last 5 years. Okay, and we need to predict, if the loan is going to be prepaid and things like that. Do you see similarities and opportunities for those methods and with those data? I will be more specific. We have all your transactions. Those are not tabular data from, let's say, a formal point of view, but not images. So we need to extract patterns from those data, from those transactional data, that need to be interpretable by the final user. For example, all your transactional data and a latent variable, let's say, could be how your regular incomes are through the years. So if there is some little regular patterns on your incomes and things like that, or spikes in your expenses, do you see how those methods could be used with the transactional data to extract those latent variables? So all the amount of transactions, the latent variable could be the regularity on your incomes, spikes in your expenses in a certain category, things like that. You see?
Yeah, it's a good question. So you mean with the particular methods of I show with the images, right?
Yeah.
Because they are generative models that learn latent disentangle factors of generation. Ideally, it should be possible. It's true that these methods are very much applied on images, and they seem to work easier there. It's not so many examples that I know of personally, but they may exist with tabular. But it's of course much more. It's also complex, and since you have some variables, depends on others. Sometimes you use relative ratios or absolute. In finance, I know it's even more complicated. So I recommend you check or survey on explainable AI for time series, where you have more this kind of data. And the field is basically it's in baby state. It's very early stage, so we need a lot of extra work on this. But there are some other methods that are similar to that to account for similarity of trends in time series.
Generating those latent variables, because not also those methods could be used at the end of the pipeline to give explanations, but also in the middle, so you have the data, you generate the latent variables that can be more interpretable, and then build your models on those.
Exactly, definitely. This is always very nice and very useful, but as you can see, it's not always evident that you have a dermatologist saying these are the things we look at and no more. But of course, in their minds, in their expertise, have some other things that maybe they cannot verbalize. So the same applies to finance, which is even more complex. How do you model that there is a war and there is a pandemic? That has never happened in your data.
Thinking of more practical use cases, so banks and loans, so account accounts.
Yes.
Yeah.
Definitely, it's a very interesting topic. I don't know equivalent technique, but it's worth doing some research, I guess.
My second question is more philosophical, let's say. Thinking about what Professor Chiara said previously about the regulations, I'm thinking about the regulations and the fact that you need to give explainability to your models. But what if the explainability method is some sort of black box? You need to understand what the explainability method is doing. Do you see some meta explainability problem from a regulation point of view?
That's a good way to call it. So you mean using a black box to explain another black box, what we were talking yesterday. Yes, this is a bit an issue. In my view, it's one way of doing. If you simplify for instance, with distillation, your model, and somehow can compress what is important, like in continual learning, distillation, other approaches. However, it's not fully satisfying for me, because I feel we are explaining a second model, not the original. And when these models may differ, can we control for it? When they differ, which one do we listen to?
I feel like there are many levels in which you have to put
I completely agree with you that if you use a black box to understand another one, probably you don't find any solution either. From one side, this is also what people working with symbolic AI say. So for this reason, there is a lot of study, for instance, to translate machine learning activation in the final decision tree, or in a rule system-based system that is at least interpretable, not explained in the JavaScript but interpretable for human, and this is based on clear algorithm, clear rule that is set. Unfortunately, this method very often cannot reach all the complexity and can represent just only very simple elements or just only 5, I think, to CNN, just to give an example, they are able to interpret just only the last layer of that one. So you can say, okay, I grab this answer or not, this one and this one, because this has a final value that is 0.8, instead the other one is just only 0.6, but is close to that, this is not that one, but is just only 0.1. So this is something that is studied. Okay, sometimes enough, because especially it's enough in finance. I read some paper on that for instance, JP Morgan provide that one in order to give at least the idea for the final user that is not any user is not taken by chance, but there is a final value. Of course, it's not what she's saying, so it's not the final research that is able to explain all of that. But at the same time, when you have one network with 50 billions of parameters, you cannot explain anything anymore. So we should find a good trade-off in order to, from one side, explain the design, the data used, the procedure for technical people, and explain the result, how much the user is satisfied. So it's become a complex system in order to be understood from everyone to everyone. But this is our role idea, not to explain everything, but at least to understand what we are doing.
Yeah, fair consideration. I feel like team a little bit. We are willing to do new things, experiment with new models, but at the same time, there is this trade-off between, okay, we cannot use this super cool neural network because on the other side, no one's going to buy it because
look, it's the same problem in the research, because people might believe that are doing new materials, are studying new materials, but my husband is a building construction company that doesn't experiment in new materials at all for new buildings. So you have to find a good trade-off. Now what is the problem is that there is a sort of so much bias, so much confusion about AI, so much publicity about that everyone would like to try, okay, you see that one on GitHub, let's I take a shot. But you understand very well that it's not exactly the same. So research labs can do, research and labs can do. If you're working in a company, you should start with something that is very expensive. And going back
also from the explainability point of view, so also the explainability.
Yeah, it's the same, absolutely. Also the explainability system we are doing is something that he's doing a PhD for that. So now what we are doing is some proposal, but it's not exactly something that
Thank you.
Yeah, you're welcome. Many challenges, of course. Very much we are all interested in this topic, so we can, of course, discuss and discuss collaborations, ideas. And okay, the second metric to look after that we can give some degree of number that we can compare is faithfulness. So in this way, we evaluate whether the feature importance, again, we assume that we get some feature importance by an explainable AI method, are correct. How? So they replace also the feature values by base values. It's that this part is similar a bit to the previous one. Like if you have reinforcement learning algorithm will be doing nothing as a feature could be, or putting values to 0 for pixels, right? In decreasing order of feature importance, which is the theta here, we compute faithfulness as the Pearson correlation of vector of prediction probabilities with the feature importance. And this should somehow give us an idea of how these two correlate. As you can see, this might not be the full picture, but the higher the faithfulness, the better the information should be, right? And the intuition is just that removing more important features should reduce the confidence more, right, than reducing less important features. So this kind of intuitive. So this process is basically done iteratively, right? And I think we could have a battery of tests that we could give. Okay, my model is more faithful than yours, but it's less monotonic. Depending on the case, you may have a criteria to choose one or another. But it would be nice to just push a button and, hey, run all my tests. This is not perhaps just in place, as data scientists and researchers, how much time it takes to just adapt your data. Okay, but still, there are great ways to go there, right? Self-explaining neural net. So this could be another nice dimension to explore. Like if we are able to explain the internal relationships when we use data intrinsic properties instead of adding costly labels, perhaps we have some brain-inspired mechanisms that we can use as explanation, and to show how this self-supervised learning is being useful to learn. They also exist some desiderata for explanations: explicitness, faithfulness, and stability. And the idea is to basically to progressively generalize, let's say, linear classifiers to more complex explicit models. You can see more in this paper. They are not always as easy as a bit we have been seeing with images in the previous dermatology example. So basically here they enforce faithfulness and stability via regularization, and let's see, basically explicitness is the asking the question of intelligibility. So are the explanations immediate and understandable? As you can see, the question is also a bit general, so of course it's not so easy. Faithfulness, or basically measure, are relevance scores indicative or of the importance? The expert may disagree. And stability says how consistent are the explanations for similar or neighbor examples. So this is not always a metric, but more, as we said, desiderata. So we may have a proxy to measure that in a task and not in another. It'd be great to generalize this. So just an example of this. As we saw, pixel-based explanation give more fine-grained, very precise explanation, right? If we have here saliency method, gradient, and the input integrated gradients that apply to all architectures with a gradient, LRP, Lime. Here, this proposed method, actually, while these are more maybe similar, and it maybe would not be evident for us to say, okay, this map is better than this other. Which one explains better the explanation of this input to classify a digit? It's maybe not so clear. Okay, here it looks really, occlusion is not working so well compared with this, right? If we are to point at the right stroke to detect that it's number 2. But what this model does is they actually annotate the, let's say, dimensions that are common and that could be identified in this number. So what could it be? So if you think concepts, they're based on concepts instead of pixels, this explanation. So if you see concept 1 is this vertical stroke, concept 2 is this circumference, option 3 is this kind of stroke, option 4 and 5. So you can see that all these concepts, this method predicts them as explanation, and you can see what is the common element between the 2 and the 9 here in these two images. One could think, or what is the common element between the 9 and the 6? It goes in this line. You have a round element, right? So indeed, actually, this feature doesn't seem to be very well captured here, because if you think the concept 2, which is this rounded element, is not detected in none of them. In my opinion, it should be detected for the 9. But okay, it seems the method is not perfect. The common element here, that is concept 3 activating as responsible for this class, it's, as you can see, is the diagonal element. So in both digits you have this diagonal element in the same orientation. So okay, nice. It seems this concept has been learned. But how to define these concepts and having these human annotations, it's to me not very scalable. Do we want to classify numbers for if they have this inclination? What about when the degree changes a bit? This is tough, right? But it's a maybe nicer, more abstract way of thinking and explaining the model than just looking at pixels and comparing. At least the model, we know it's learning some more high-level, let's say, morphological feature. This could be applied also in other cases, right? Okay, in the second, here I have more ethical debate part, where some real cases, as yesterday we also shown. This is from a program I was working during a summer that I actually recommend, really nice, from NASA, ESA, and SETI Institute in California. And you work during the summer in a very intense sprint to do cool projects. You learn a lot, so I recommend you applying. And I thought we were doing very nice project where everything was good, but as I said yesterday, it was not. This is the program. It was not as well seen by reviewers of our paper. So these were our team. If you want to celebrate your project, you have to account for all these things from the beginning. So I just want to remind you a bit of all these ethical steps that you may actually think about it. This is to remind you the system we have. We have a picture before flooding and after flooding from satellite images, because we know from many catastrophes that have happened how the satellite looks before and after. We can train a gun, cycle gun style, where given these two domains, it learns to generate how the area will look when flooded, right? So this seems to me very good to create awareness for, we said, as how climate change can affect our actual house or actual backyard, city planners, right? And you can see that even though it's a very internationally trusted source, satellite image, to analyze deforestation, development, or military, we got some critique like saying, okay, guns shouldn't be used to generate fake images of natural disaster because there are many lives in danger. It's true. We need to be aware of this, and we need to specify the limits of our model, right? So, and they also said something like, guns are not good techniques if we want to help decision makers. I thought they were. What else can we use? I mean, of course, if we don't have data that is real, if it's the best we can do, to visualize or to help decision making. Of course, in the last instance, we need to make sure that it will be the decision maker taking the decision, right? But they were also worried that satellite imagery and machine learning may become untrustable because studies like this are creating fake satellite images with the only goal of scaring people. So these are the kind of comments we got. It touched my heart because I worked really hard on this project and it's a lot of work, as you can imagine. So we need to learn to protect our models but also make them safe and to have their limitations, to specify them and to make them trustable. Otherwise nobody will buy them, or you will have always skeptic people with whom you may at the end they may hinder the usage of something that can be a tool in order to help. More generally, of course, tools can be used for help or to damage, to make damage. So yeah, this is why since this moment I became more mindful about ethical AI, and this is just to give you an example of how your full research can be thrown down by if you don't think about consequences, right? So very important to think about this area. So what could go wrong also with guns? So this is a nice post you can read for guns for good. As you can see, many dangerous applications can be built indeed, but also good ones. So we have to, the more we are able to explain them, the better will be the deployment and the impact, right? How to mitigate bias, very important. All the field of AI fairness, it's working on this, many frameworks where they've shown that it's not always possible to optimize all the fairness constraints. Perhaps you have to choose. So we all need to be more educated in that areas to enable accessibility, inclusiveness, fairness. So always make sure that we democratize our work. It doesn't look like a magician work, so that people don't get scared, like this reviewer suggests. And sadly, it's true that many people are affected this way. If some harm can be caused, avoid publishing. Make very sure that how your model can be used for good. Who is the audience? The consumer versus the user is probably different. You need to specify, right? What questions should we pose before planning a new project? It might be that this regulation will just forbid your system. So maybe now at least we have the regulation, even it's being drafted, but now we all need to read this regulation with, it's not easy for engineers like us, but we will have to embrace it to pose a project before it's turned down. A lot of effort is turned down. It's not, we want sustainability of our projects also, right? We know the interdisciplinary is challenging, but it's necessary every time more in this kind of situations with social sciences, humanities, and also when it's interdisciplinary, it will be more challenging, but it will be more rewarding and more impactful. If we can link it to the Sustainable Development Goals, it will be already insurance that we are in the right direction, right? And in pointing at them, it might be very good justification to show how many of these goals your project is contributing to. So let's think a bit about what could be the risk of these AI products. Like, the biggest companies are using child in mining cobalt for technology products. This can at the end up in discrimination and abuse of labor. So it looks like things that might not be connected, but indeed there is always a connection that we may not see, obviously. This is what I want to make you aware and to make you think, which is not obvious always. So they have been accused of a lawsuit, these largest companies, because some of these children are exposed to lithium batteries and they are suffering health and even to death sometimes. So in the end, they might be doing responsible AI principles, but we also need to account for other consequences of this. Another risk is the technological, apart from the energy and mineral resources, another risk is the technological oligopoly, where we can see that perhaps science in labs, it's hard to compete with these bigger companies like it was indicated earlier. Now only these large hardware companies can afford solve things that have been taking ages before. So we need to control also for this, so that it's still not all put relying on a company. Another risk, the lack of transdisciplinarity and diversity, like lack of women sometimes, or lack of other minorities to have all the perspectives of a problem. With the more brains, the more we can think about different risks, and the more we'll be able to prevent future disaster, future consequences. Probably you have seen this consequence of Google classifying images, that he felt that when recognizing, it was labeling black people as gorillas. This is really bad, and it shows basically the bias of the data to white men. What did they do? They recognized the error, but in the end, what they did is removing the class gorilla. What about if we want to use this API to actually preserve diversity of a species that is in danger, or it's a kind of gorilla? It can have other consequences. That's not the panacea. It's not the solution, right? But imagine how hard it is to correct this bias if this was just removing. So it means it's not, if Google cannot fix this problem, we need to seriously account for the quality of our data, because at the end it's going to be crucial for our models. Still, I think this gorilla remains in some Google products like Google Cloud Vision API, but this is something bothersome, right? You could have other similar consequences. Okay, more examples. Here, the face is not detected for a black woman. You give a score of gender, detected, not detected. They compare different systems of face recognition. You can read this post. And for instance, errors of this model is that they don't distinguish identity and biological sex, only feminine and masculine. Simplification, while reality is more complex. And all the systems actually provide better performance to men of white skin. So everything that is not that, it gets lower performance. This is also worrying. Here you see a bit, according to the type of feature, all the accuracy disparities. So these are interesting analyses that we should do. Because indeed, IBM has the largest gap in accuracy between some of these groups, and up to 34% actually. 34% is quite a lot in between one type of image type, darker female or lighter female. Being a female, you are already most likely to be wrongly classified. So basically this takes us to the lack of diversity data and training data benchmarks. You can see or join the algorithmic justice league Maybe some of you have watched the movie Coded Bias. It's, I think, a good movie in this area. So it's important to know we are risking losing gains that we have made through years in human rights and gender equity, other equities, under the guise of machine neutrality. Just thinking that the machine learning models are neutral and just learn from data, we might just lose everything we gain. So things that we have fighted for long, they can be put in a game and be lost this way. Do you realize? Another example, you put a translation from Polish when you have some gender neutral pronouns, and when it becomes too beautiful it's assigned to she, when it's clever it's assigned to he. This is another example of bias in language and all this that comes along. He makes a lot of money, not she. And who bakes a cake? It's she. He is a professor, she is an assistant. Already showing bias. What about generative models? More examples. This is much more worse than expected. This I borrow from Virginia Dignum, who created this test on the generative models, and I think it's a very nice example to show. You see the bias. You put a nurse in front of a hospital, and you see it's always a woman on the left. If you put a doctor in front of a hospital, a doctor could be also a woman. Why it just draws a man? So we need serious measures to ensure that these tools expose the bias and communicate the bias too. Especially when there is gender-neutral words, this is it's easy to show. This is a similar example with the GPT example. So you give in yellow the change in the input, and gray is the generated text, and the bias is in red. So when you put the America describing an accident, the African American driver identified as blah blah, arrested, and what's the conclusion? He gets a maximum penalty. While if you actually say that the driver is a white male and the car was arrested, etc., but at the end is released without incident. Can you see? So, just for being African American, it's the outcome like this. So this needs to be really controlled. It's not easy. And we need to be aware. There are some books on this area. It's already 1 o'clock, so this is a link I leave you in the slides. I'm interested if this talk and these concerns I raise some problem in your company or in your research project. I would like you to do this exercise. It will be useful for the future, and you can add your comment in this link. It would be great to work on tools together that actually tackle these problems. Because that's the first step to have AI accountability, blaming what is the cause of having biased data, right? And problematic models. So I leave you here the practical tutorials links where ideally I don't know if because we started a bit later, but I leave here to you the links to this project. The idea is that we will work with a partner in the room or that you work with. Choose an example in the AI IBM toolbox, study, and then explain the method to another partner. It's not always easy, right? But that way you can learn about two. Then you switch roles and you learn about two explainability techniques. Then you have other extra tutorials on SHAP, GradCam, on some lymphoma, esophagus classification, animal classification. So, and another article we tried we put together some other techniques for text or other data that it may suit your needs. Here I leave some acknowledgements of people that have contributed material and good tutorials to read more and learn more about explainability. I hope this raises your interest in the topic and it's more clear to you what that means. And this is the end. So if you want to keep in touch, I'll be happy in any of these ways. And this is a nice message, I think, from Macron a few weeks ago, that he basically showed that the geopolitical moment currently, it's much more critical, I think, that we are aware. So it's the end of the abundance, liquidity without cost, materia prima, creo que Martin, you understand, natural resources, technology. With the lack of chips and the technological bans, we might not be able to have computers and deep learning resources soon. With the ban of Asia and US and the cold war sanctions, let's say. So this is all very worrying, and it's the end also of the evidence, like the liberty, democracy, human rights. So we need to be very careful and very much predictive about what can happen. We may lose basic elements, and the end of unworriness, like being relaxed, because war, climate, cybersecurity. So I think it was. This is a good summary. So I end here, and thank you so much for your attention. If you have questions, of course, you are welcome to ask or interact.